Hi, welcome back. In this class, we'll see some more examples on Pandas data frames. Let us start with, let us use one data frame we created last time. Yes, I think I said df5. And first, let us see how to drop some rows. We can say df5 dot drop, and we can pass a index. I'll say drop row f, this one, and if I execute this one, so that f will be dropped. Let us see if it is already, it has dropped from df5. No, it's not dropped from df5, but the output we get is a new data frame without the ef index. And also we can drop a column. Let us try to drop, let us say column 5. If I say, I will say df5 dot drop, and I'll say column 5, and here we have to specify the axis. Axis is 1. For columns we have to specify axis is 1. The default is 0. That's why we didn't specify when you are dropping a row. Here we didn't specify the axis because the default is 0. For rows the axis is 0, and the columns the axis is 1. If we do this one, it'll get the column 5 is dropped now. All right. And next, let us see data alignment in data frames. I'll just copy a data frame. Say copy, I'll say D6. This is a D6. A small data frame with 4 items with where here, let me explain this. We are creating a data frame. For the data we are using a np.numpy range and reshaping to as a 2x2 matrix. And for columns we are giving a list, and this will create a list object with the 2 items A and B. And similarly for the index we are creating X and Y. So that is our df6. If I execute this one, that is the data frame we get. Data frame with 4 values, and these are the indexes and these are the column names. And similarly, let us create one more. I'll say df7 and df7, and here let us create a 3x3 matrix, 9, and I'll say 3 and 3 and C and Z. So we are creating the df7 is a 3x3 matrix. Let me execute this. Say here it is. These are the values, and these are the columns column names A, B, and C, and X, Y, Z are the indexes. All right, and let us do. If I say df6 plus df7, this is what we get. Let us see what we got. We got A and B here. df6 has only A and B, so all the values are first A's of we get 0 plus 0 0, and 1 plus 1 is 2, and similarly 2 plus 3 is 5, and 3 plus 4 is 7. And because there is no C's in df6, so it filled up with null values. And also here, because there is no Z in df6, so it got all null values. That is when you do a df6 plus df7. And also there is another way to add. We can say df6 dot drop add and df7, right? We are adding df6 to df7 by using the method add method, and here we can specify the field values also. I'll say field value. Here we get a different result here now, 0. If I execute this one, this is what I get. So we got all the ABCs are filled, all the C's are also filled, and the C is filled with this one, 2, 5 and 8, 2, 5 and 8, and it treats the df6 values as 0 because of this fill value, and G's are filled. G's are filled with 6, 7 and 8. So that is about add. Let us see some more operations. We have this df5, right? We have df5, it's intact. I'll say I'll create a df8. I'll create df8 equal to df5 dot drop. I'll pass a list here. I'll pass a list of rows. I'll pass a dot f, right? And also z. I want to drop these 2 rows. So z, and also I want to drop some columns. I'll say df9 equal to df8, right? And here I will, dot drop. Here I will pass some column names. Say call, I'll say call 4, call 4 and call 6. Okay, that is I'm passing as a list. And also because when you pass columns, you have to specify access. Here the access is 0, which is the default, and I pass a access 1. And let us print df9. We made a mistake. df8, df5 drop. What is G is not contained in X. Where did I say Z? Okay. F. I put a space here. That's a mistake. So that's what we get. We're dropping F and Z rows, and also we're dropping columns 4 and 6. See, there's no column 4 and 6 here. So that's how to drop columns and rows. And also we can find the sum. I can say, I'll say df9 dot sum. It will give all the sums by columns. This is the column 1 sum is 307. Similarly here it is 307, 231 and 262. All the sums by columns. And also we can get by rows. I can say df9 dot sum. What we have to do, we have to say the axis. Axis is 1. Here is reversed. The axis here we are specifying, but the rows we are specifying as 1. Alright, if you specify axis as 1, it will give you by rows. Alright, that is about. Also we can find the maximum. I say df9 dot max. If I do df9 of max, I'll get let us print out 9. Alright, df9 max, column 1 max is 91. The max is 91. Alright, this one column 2 is 95, and here it is 61, and column 5 is 94. Alright, and also we can find, similarly we can do df9 dot min. Next there is another method I'll say df9 dot idx max. If I execute this one, I'll get the indexes. For example, in column 1, the column 1, I got a B, means index B, means the maximum in this column is at index B. That's what it says. And also in column 2, I got a C, means the maximum of this column is at index C. Similarly, in column 5, the maximum is at D, maximum of that column. So that is the purpose of the method idx max. And also there is idx min is also there. You find the index where the minimum of that column is there. Okay, let us see the df9 is this one. There's something called cumulative sum. We can say df9 dot come sum. Cumulative sum will give C is 83 plus 91 is 174, and 174 plus 8 182. So it gives the cumulative sums of all the values in a column. Similarly, it starts from 7 plus 31 38, 38 plus 79, you get 117. Okay, that's about cumulative sum. Also there's a method called I'll say df9 dot describe. It gives some statistics about this data frame. Describe. It will give how many rows are there, how many indexes are there. There are 5, so it gives 5 in each column, and what is the mean in each value in each column, and what is the standard deviation, what is the minimum, and what is the maximum, and all that. All right, let us create another data frame. I'll just copy the code so that it will be faster. I'll explain what I'm doing here. So first I just created some variable called nd. nd is np.nan. Instead of using always np.nan, we can do this too. And then I am creating 2 for lists, a, b, c, d. First one is a 1 to 3, second one is 4, and there's no value here, and 6. And then in list 6 c, there's starts with nd 8 and nd, and d as all the values are null values. And I'm creating a data frame using 4 lists. These are the values, and let us see what I get. I'll say this is how much is now. This is df10. All right, and df10. And if I execute this, this is what the data frame I get. First one is 1 to 3. So he got 1 to 3. These are generated. The column names and the indexes are automatically generated by the pandas. We didn't specify here in this when we are creating this data frame, we didn't specify columns and the values. That's why it automatically created with numerical values 0 1 2 and 0 1 2. All right, here we have just specified 4 list objects. So each list object becomes a row in the data frame. Each A is a list object, B is a list object. Each becomes a row in the list data frame. All right, first one is 1 to 3, and the second one is 4, no value, and 6. All right, and that's how it is created. The last one is all null values. And we can say there's a method called df10 dot drop NA. If we execute this one, we get so wherever there is a null value, it will just drop that one. So finally we got only 1 to 3. So only this data we got, because all the other rows are having null values, so it dropped. Okay, then we can say there's another, we can say df10 drop, and you can specify how to drop. We say how all means only if drop only if all the values are null. If you execute this, got unexpected how drop, oh sorry, you have to say drop any. If you execute this one, it drops the last row, because only it will drop only if all the values are null values. Okay, that's why it dropped everything and the remaining were there, 1 2 3 and this, all this. And also you can specify a threshold. You can say drop only, I'll say, let me copy this. You can say thresh equal to 2. Let me print out this first, df10, like that. Then let me, and then I'll say drop where the threshold is 2. Let us see what we get here. Means at least keep if the values are at least 2. Here it is 3, here it is 2. So here we have only 1. That's why it's not keeping this one. It is just keeping only these 2 rows. All right. Here there's no values here, but at least if there are at least 2 rows or 2 values are there in the row, just keep that one. And if I say threshold 3, it will keep threshold 3 means there must be at least 3 values. That's why it kept only this one. Okay, and also df10, we can say df10 dot fill all the null values. Let us say with 100. We can say all the null values are replaced with 100. df10 is still there's no change in df10, only the output is showing as the changed values, but we can change the values too. We can say, of course we can say df10 equal to df10, and we can do that. Also there is something df10 dot fill NA. I'll say replace all null values with 0, and we can say in place equal to true. If we do this one, it will replace the original data frame. And if we say df10 here, so all the null values got replaced with zeros. Okay, let us stop here, and we'll meet in the next class and do some more operations on this data frame. Okay, thanks.